Hello everyone, welcome to this video. In this video, we shall see a question from June 2019 consisting of 4.75 marks. The question says, if n be any integer, then which of the following is correct? So among these four, what is the correct option, right? So they are given this polynomial x cube plus nx plus 1. Now they are asking whether this is irreducible or reducible over z for every n, for n belonging to the set 0 and minus 2, for n not belonging to this set, and for infinitely many n. So let us see for what values of n the given polynomial is reducible or irreducible, right? So let us proceed for option number B. For this option we have this polynomial, right? X cube plus nx plus 1. Now we need to check it for two values of n, that is 0 and minus 2. So let us substitute n is equal to 0 into our given polynomial. So our polynomial x cube plus nx plus 1, now this term becomes 0, therefore we are only left with x cube plus 1. So we can easily factorize this by using the cubic formula a cube plus b cube, that is equal to a plus b, and a square minus ab plus b square, right? So we can use this formula. So we'll obtain these two polynomials. Therefore from here we see that x is equal to minus 1 is a root of this polynomial when n is given to be 0, right? So in this case we obtain the given polynomial as the product of two polynomials. Therefore the given polynomial becomes irreducible by its definition. Another thing, when we substitute n is equal to minus 2, here the given polynomial, in the given polynomial we substitute n is equal to minus 2, so we have this term, right? So this term, right? So this is the thing. Now we need to check for root. We can go by hit and trial method. So you'll see when you substitute 1 into this polynomial, you'll obtain 0. It is quite obvious that it is minus 2 and 1, and if you substitute here 1 also and here 1, you'll get 0, right? So x is equal to 1 is a root for this polynomial when n is equal to minus 2, or in other words we can say x minus 1 is a factor. Therefore by definition this polynomial becomes irreducible, right? Therefore for these both these values of n, 0 and minus 2, our polynomial is reducible. Therefore this option is correct, right? Option B is correct because it is reducible over z. Now look at option number 1. It says that the same polynomial is irreducible over z for every n. Now this thing is not true because we have just seen that for n is equal to 0 and for n is equal to minus 2, our polynomial is reducible. Therefore this option is incorrect. Now for the third option they are asking, this polynomial is irreducible over z if n does not belongs to this set. We have verified the result that whenever n is equal to 0 or minus 2, our polynomial is reducible. Now, is there any other n such that the polynomial is reducible? If not, we can say that this polynomial is irreducible over z for every value of n except these two. So we need to look for any other values apart from 0 and minus 2 of n such that the polynomial is reducible. If so, this option is incorrect, right? So for this we can use this result, rational root theorem. That means if we are looking for some rational root of the form p upon q, where this p and q, they are relatively prime and both of these come from the set of integers, right? So in that case this is a root of fx if the numerator p divides the constant term of the polynomial and that this denominator divides the leading coefficient of this polynomial, right? So in our case the polynomial is given to be x cube plus nx plus 1. So a rational root of this form, rational root obviously include integers, so it's better to check for the rational root, right? So here p should divide the constant term, that is 1, and q should divide the leading coefficient, that is also equal to 1. So p should divide 1, that means p could either be plus minus 1 and q could also be either plus minus 1. Therefore this rational number p by q, that is either equal to plus 1 or minus 1. When x is equal to plus 1, we just saw what is the value of n. When x is equal to plus 1, in this case, we have the value of n as minus 2, right? And when x is equal to minus 1, the value of n is equal to 0. Therefore, the only possible rational roots are x is equal to 1 and x is equal to minus 1. And for these, we have the values of n as minus 2 and 0. Therefore, the polynomial f of x, this is reducible, or it has a root whenever n is equal to 0 or it is equal to minus 2 only, right? So this option is incorrect. I'm sorry, this option is correct because we do not find any other n for which this polynomial is reducible. Therefore, this polynomial is irreducible for every value other than 0 and minus 2. Similarly, the fourth option says this polynomial is reducible over z for infinitely many n. Now, we found that the polynomial is reducible over z for only n is equal to 0 and minus 2. Therefore, these are finite numbers and not infinite. Thus, this option is incorrect option, right? So, only correct options are B and C. Well, from here, on the basis of roots, how did we say that this polynomial is reducible? Because for degree 2 or degree 3, we have a result that if you found any root for this polynomial, then that polynomial become reducible, right? So I hope that this question is clear. Well, thank you for watching. I'll see you in the next video.